Welcome to my YouTube channel Statisticians Club. I hope everyone is fine. Please subscribe the channel. Also press bell icon to receive latest videos about regression analysis and econometrics. Today I discuss degree of freedom in statistics. In my previous video I defined the degree of freedom, the total number of observations minus the number of parameters to be estimated. This is the definition of degree of freedom that we discussed in previous video. So in statistics, degree of freedom represent number of independent values in an analysis that can vary freely without affecting any constraint or parameters. Now we discuss degree of freedom for t distribution. Here I take example from one sample t test in which null hypothesis is statistically significant or insignificant. That is our task. And in one sample t test, the degree of freedom is n minus 1. This is the formula of degree of freedom for one sample t test. N represent the sample size and 1 indicate the number of restrictions or parameter to be estimated. Let's suppose in one sample t test for mean, we determine the hypothesis which is statistically significant for mean or not. So the parameter to be estimated is mean. So this parameter set this formula, total number of observation minus parameter to be estimated. In last video I give the example number second about mean and prove how one observation is not freely to vary. Degree of freedom is closely related to sample size. As you know, as the sample size increases, degree of freedom automatically increases. For example, if our sample size is 10, the degree of freedom will be n minus 1. 10 minus 1 is equal to 9. Our sample size is 20, the degree of freedom will be the 19. If our sample size is 50, the degree of freedom will be the 49. So degree of freedom is closely related to sample size and it has effect on the shape of the t distributions as well. Degree of freedom for chi-square. As you know, the for chi-square test degree of freedom is r minus 1 and c minus 1. For test of independence, here r is the number of rows and c represent the number of columns. We create a 2 by 2 contingency table to prove this formula of degree of freedom. Here this is our table of 2 by 2 contingency table. Any city, two groups A and B. We divide these groups according to two categorical variables, married population and unmarried. Here is the total row wise, this is the total column wise. Suppose these total of black observations, the observations that is written in black letters, these are the given already, and suppose these red and blue observations are blank. So we can set here observation is 70. We are free in this cell. We set these observations also 65, 55, any observations. But at once, when you set these observations, these R blue observations are not free to vary, because here is 70 population, 70 minus 110, 40. These observations will be 40 in every condition. This may not be 41, 39. No, this is the these observations will be 40. And here this is 100 already given, and this is the 70. 70 minus 100, 30. In every condition these observations will be 30. This is not free to vary. In this cell we already know this is 40. 40 minus 50 is equal to 10, or 30 minus 40 is equal to 10. So this observation is not free to vary. So in R4 cells only one observation is independent. This one observations will be this 30, this one. Any observations we know, we on the behalf of these observations and these totals we can determine all three observations. So four in these four observations we are we have only one cell in which we are independent to vary. Now look this formula. R minus 1, R represent rows. Here is two rows of this contingency table. 2 minus 1, C minus 1. C represent the column. Here is the two columns. 2 minus 1, 1 multiplied by 1 is equal to 1. The degree of freedom is 1. This 70 represent the observations that is free to vary. Now we move towards next 3 by 2 contingency table. Here suppose any one city, we select three groups A, B, C, and we divide the population into two groups, married and unmarried. And suppose like previous example, these black letters are given, and suppose these 6 cells are empty. We have no observations there. So first we go in this group, we write 55 here. We are independent to assume these observations. These observations may be 60, 45, 50. We are independent to vary here. And on the behalf of this 100 minus 55, 45, we are not free to vary these observations. This is fixed. This will be the 45 in every condition. Now we move towards next group in B. Here in this cell we are free to vary. Any observations can assume this is 30. We can assume also any other observation 25, but we write here is 30. Now on the behalf of this 50 minus 30, 20. This will be the 20. This cell cannot vary. 130 minus 30 minus 55, this will be the 45. Similarly 50 minus 45, this will be the 5. So these all blue observations are fixed. These all observations are not free to vary. Only the two observations are free to vary. Now I look the formula. Degree of freedom of this table is R minus 1. Here is R minus 1. Here is two rows. 2 minus 1. C minus 1. This is the three columns. 3 minus 1. 2 minus 1 2. The answer is 2. Degree freedom of 3 by 2 contingency table is 2. So as you see, here is the two observations that are free to vary. Similarly, t distribution, the degree of freedom also define the shape of the chi-square distributions. So degree of freedom also used in F statistics, regression analysis, and similar concept apply in all kind of formulas. Uh, uh, that is the observations that is free to vary, no restrictions imposed on that observations according to the name. This is the degree of freedom, means free to vary. Thanks.